Hi, my name's Adrian and I'm a senior lecturer here at the School of Engineering at the University of Waikato. And my research is about time-of-flight 3D cameras. And this type of technology is usually used for applications that we call machine vision. And machine vision basically means computers measuring things, measuring the size or the shape or the location of objects in a scene. So a normal 2D camera makes that a bit difficult. But the 3D camera gives the computer that extra perspective and lets it perceive the world in the way that we perceive it, which helps it make the measurement. So we do a lot of that research here in this room, and it involves lasers, and we have a laser warning sign here on the door, which means normally we need to wear our safety eyewear. But I don't need that today, so come on in here and get a new perspective on our research. When I started working in electronics, I was working for the what was called at the time the Defence Scientific Establishment. It was on the Devonport Naval Base in Auckland. So I worked there for a few years and then decided to come to university and did my PhD degree here at Waikato, working on LiDAR for measuring wind speed. And after I finished my PhD, I did a postdoc in the US at the NASA Langley Research Center. And that was looking at methods to measure the shape and the size of inflatable space structures. It's quite an interesting topic because if you want to build something that's fairly big in space, then you've got two options. The rockets are only a certain size, so you can either take it up in parts and assemble it while it's there, or you can make it collapsible, so it folds down to a small space, send it up into space, and then inflate it. So we're looking at these inflatable objects, but the designers weren't entirely sure if they were going to inflate to the correct shape. So we were looking at methods to measure the shape of these just to test to see whether they've inflated correctly. And then I did that for a couple of years and then came back here to Waikato to do another postdoc when I started working on the time-of-flight 3D imaging that I do now, which is, again, it's measuring shape, but it's using a different technology to what I was using at NASA, but the same sort of theme, really. The technique that we were using at NASA is a technique called photogrammetry, and that basically involves two or more cameras looking at an object from different points of view. And because they're looking at different points of view, you can take these two images it sees and basically do some back projection to figure out what the object is like in 3D. What I'm doing now is it still measures the shape of the object, but now we do it from only one point of view. And it's called time of flight because the camera sends out some light and it measures how long that light takes to come back to the camera. So once we know how long it takes, and of course we know the speed of light, then we can work out the distance for each pixel in the scene.